let's get pumped up for example 4. Woo, woo. All right, let's do it. Example 4. So, again, I tried my best to draw my picture, but if you see, it's highly embarrassing. So I hope you guys do a better picture. So, the top of a lighthouse, this is the lighthouse. I know it doesn't look anything like a lighthouse, but I tried. All right, the top of a lighthouse is 120 meters above sea level. So we got the lighthouse right here. Lighthouse. We have sea level right here. Hence the sea. Alright, so it says the top of a lighthouse is 120 meters above sea level. Okay? So that distance is referring to basically the height of the lighthouse. So this part of the lighthouse, the top of the lighthouse is 120 meters above sea level. So that is referring to this side of my picture, 120 meters. The angle of depression. So we're dealing with an angle of depression right now. So our angle of depression from the top of the lighthouse to the ship is 23 degrees. Okay, so first of all, we're dealing with an angle of depression this time. The angle of depression from the top of the lighthouse to the ship is 23 degrees. So probably what this is referring to, you guys, is when the lighthouse projects the light to the ship, it starts off when it shoots out the light horizontal, it's right here, but then when it aims it toward the ship, the angle heads downward. Okay, so this is going to be an angle of depression. So the angle of depression is from the top of the lighthouse, and then when the light shines downward, it creates this lovely angle right here of depression, and that is 23 degrees. Okay, it says how far is the ship from the foot of the lighthouse? So here's my ship. I want to know how far away it is from the ship to the foot or the bottom of the lighthouse. Okay, so the part of my triangle that I'm solving for is this one, this side. Okay, and if you guys see here, I've secretly kind of hidden this right triangle right here. So in order to do these problems, you guys have to somehow form a right triangle, okay? Which my right triangle, it's hard to see, but my right triangle is right here. Okay, which, let me think for a minute. Okay, so my right triangle is right here, if this helps you to visualize. So here's the right triangle, right here. It's the highlighter yellow, not the light yellow. All right, so it's the highlighter yellow right here. Probably should have used a different color, but whatever. All right, but anyway, so how far is the ship from the foot of the lighthouse? Now, you're probably like, well, I have two sides either given to me on my right triangle or that I'm trying to solve for. But in my right triangle, what is the key part that is missing in order for me to use the sine, cosine, and tangent? Well, in order to use sine, cosine, and tangent, you either have to be solving for or know at least two sides of the triangle, which I have that. I know one side and I'm solving for one side, so I have two sides I'm working with. Okay, but then you also have to have an angle inside of your right triangle that's not the right angle. If you look inside the right triangle, so this is not the right triangle right here. If you see, I don't have an angle given to me. But the angle of depression will help me to get an angle inside of my right triangle. Okay, if you see here, if I trace the angle of depression, and then I trace this angle right here, do you guys see a letter forming? Holy hot dog. Do you guys see the Z? What are the angles that make the Z shape? They are alternate interior angles. And how do alternate interior angles relate to each other? Well, they are congruent. So these two angles are congruent. So this is the angle I'm actually going to be working with to help me solve. Guys, so anytime you have an angle of depression, you can use an alternate interior angle to get the angle of depression into your right triangle, which is pretty cool. Okay, so other than that, now I don't need to use this angle of depression. So we kind of have to use the angle of depression to get into the right triangle, but then after that, we don't really use the angle of depression anymore, okay? But that is how we're going to solve. So now I have an angle right here in my picture, and now I need to label the parts of my right triangle to help me solve for this missing side. The distance, because it says, how far is the ship from the foot of the lighthouse? That's what I'm solving for. All right, well, let's do it, you guys. So, I need to label my sides. Okay, this is the side that's directly across from my angle, which means it is the opposite side. This is the side that is right next to my angle, but it's not the hypotenuse because the hypotenuse is the side across from my right angle. So which side is the side of my right triangle? That would be the adjacent side. Sorry. I was going to say adjacent. It came out completely wrong. The adjacent side. That's what I meant to do. Sorry, guys. But anyway, so which trig function deals with an opposite and an adjacent? That would be tangent. Tangent deals with an opposite and adjacent. I cannot say that word today. The demon cats are getting me. Get it together, Miss Long. Sorry, guys. But anyway, so I'm going to be using tangent because tangent has opposite and adjacent. There we go. Okay, so we have tangent of the angle. The angle is 23 degrees. And that will equal opposite over adjacent. See, I'm getting better the more I say it. Okay, and since I'm solving for my two sides, my opposite side is the 120. Let's see. All right, and then the C level, the adjacent side, is the side we're solving for, the X. Okay, and since I'm solving for a side of a right triangle, this is when we're going to cross multiply, so let's do it. Let's start this way. X times tangent 23 is X tangent 23. Okay, and now let's go the other way. So 1 times 120 equals 120. All right, so now I need to solve for x. Currently, the x and tangent are secretly multiplying together. So how do you move tangent to the other side? Well, you would divide that bad boy on both sides of the equation. Okay, which the two tangents of 23s will cancel out. So we're left with x equals, let's see here. I'm going to bring it up here because I'm out of space. X equals 120 over tangent of 23 degrees. And guess what? From here, we type it in our calculator. And again, since we're solving for the distance from the ship to the foot of the lighthouse, the distance in the problem that was given to us is in meters. Okay, so my final answer will be in meters. So let's do it. All right, pull out your nifty calculator if you like typing it in on your calculator. Okay, so I have 120 divided by tangent of 23 degrees. Close that parenthesis. Okay, so the ship is 282. Again, it didn't tell me how to round, so I guess let's round to the nearest tenth. Again, it doesn't matter since I didn't tell you. So that 0 will not bump up the 0.7. So it's 282.7 meters. So x is 282.7 meters. And again, real quickly, I'll type it into Desmos for you, for my Desmos loving folks. Okay, that would be 120 divided by or slash the tangent of 23. So there you go, 282.7, which is what we got earlier. Again, if you click on the function button and click on trig, you can get the tangent also by clicking on that. Well, there you go, you guys. We got one more problem. Let's get that problem done with. Let's do it.